Dear students, today we will discuss about what are the symmetric matrices and positive definite matrices. First, you know what are the symmetric matrices. You have to know what are the symmetric matrices. A square matrix X, a square matrix A is a symmetric matrix if the matrix which is equals to transpose of that matrix. Okay, that is Aij is equal to Aij. A matrix which is equals to transpose of that matrix, then that matrix we call it as symmetric matrices. Example: 3 minus 1 1 minus 1 5 minus 1 1 minus 1 3. Here A11 is 3. Okay, then A21 is minus 1, then A12 is minus 1, and then A21 is also minus 1. Then A13 is 1, A13. Then A31 is also 1. Therefore, and also A23 is minus 1, and A32 is minus 1. Therefore, we call this matrix as symmetric matrix, which equals symmetric matrix. A transpose is nothing but that same matrix, that same given matrix. Therefore, the given matrix is the symmetric matrices. Okay. Next, positive definite matrix. What is positive definite matrix? A square matrix A is positive definite if A is symmetric. First, that positive definite matrix is A is symmetric and all its eigenvalues are positive. All its eigenvalues are positive, or all its pivots are positive. Pivots means this element, pivots, diagonal elements. If A is 3 cross 3 matrix, then all its determinant, upper left determinants of order 1, 2, 3 are positive. Okay. Then we will see example. Okay. Here, the upper left is if all its eigenvalues are positive. For this, eigenvalues are try to find out the eigenvalues of for the matrix S. Therefore, S minus lambda I, which is equal to this is the characteristic equation. Therefore, 5 minus lambda 6 7 minus lambda, which is equal to 0. 5 minus lambda into 7 minus lambda minus 6 into 6, that is 6, which is equal to 0. Are the eigenvalues? 5 into 7, 35. 5 lambda minus 5 lambda minus 7 lambda minus 12 lambda minus lambda into minus lambda plus lambda square minus 36, which is equal to 0. Therefore, which implies lambda square minus 12 lambda minus 1, which is equal to 0. Therefore, we get lambda value as lambda 1 is equal to 12.083, which is greater than 0, and lambda 2 as minus 0.083, which is less than 0. Therefore, the given matrix is not a positive definite matrix. And also, this is test 1. Okay. For this test 2 means eigenvalues. Test 1. Pivots are positive. Pivots are positive and its determinant is positive. Then that matrix we call it as positive definite. Then first pivot of this is 5. Therefore, pivot First pivot is 5, which is greater than 0. Therefore, and determinant of S, which is equal to 5, 6, 6, 7. Therefore, the determinant is 5 7 is 35. 35 minus 36, which is equal to minus 1, which is less than 0. Which is less than 0. Therefore, the given this is negative. It is not a positive. The pivot element is positive, then the determinant is negative. Then that matrix we call it as positive, not a positive definite matrix. The given matrix is not a. The given matrix A is not a positive matrix. Positive definite matrix. The symmetric matrix and positive definite matrix. So next is singular value decomposition. This is the problem for 8 marks, which will appear in the model paper question. Model question paper. Okay. What is SVD? SVD we shortly call this as SVD, singular value decomposition. Okay. SVD is a method. Is a method of decomposing a rectangular matrix. The given rectangular decomposing a given rectangular matrix into 3 matrices. Here 3 matrices. U is a U and V are orthogonal matrices, and summation is a diagonal matrix. Okay. Then we will see some steps involved in solving the singular value decomposition. Okay. First step, find A transpose into A. Okay. Multiply A transpose matrix and A matrix, and in second step, find the eigenvalues and eigenvectors and arrange them in decreasing order. Okay. Find, as we have discussed about in the previous classes. Discussed about these in the previous classes. So you have to find the eigenvalues and eigenvectors, arrange them in the decreasing order. Okay. Then find the singular values. How to find singular values? Using eigenvalues, we find the singular values. Sigma 1. Singular values are called in terms of sigma. Sigma 1 is equal to root of lambda 1. Lambda 1 in here, lambda 1 is nothing but eigenvalue, and sigma 2, which is equal to root of lambda 2. Lambda 2 is the eigenvalue, therefore, and so on. In step 4, find the eigenvectors for each eigenvalues. Find the eigenvectors in the corresponding eigenvalues. Okay. Then in step 5, calculate U, V and summation matrices. Here, to calculate U, we have U1, U2. How to find U1 and U2? U1 is nothing but A V1 by sigma 1. Here A is a given matrix and V1 is this matrix. We have to find V1 and sigma 1 is the singular value. Okay. Then A V1 by sigma 1, A V2 by sigma 2. And how to find V1 and V2? V1 is nothing but x1 by x, norm of x1. Here x1 is the eigenvector. Here x1 is eigenvector corresponding to first lambda, first eigenvalue, and norm x1 is nothing but the norm x1 is square root of x1 square plus x2 square plus so on. Okay. In the last step, we verify whether this is equal or not. U summation V transpose. Therefore, here V transpose is transpose of V. Therefore, if in step 6, this is the last step. If this multiply these 3 matrices, we get A, then the matrix is singular value decomposed. Singularly decomposed matrix. Okay. We will solve some problem on this. So now we will see how the SVD process is going to take place. Okay. In first step, we have to find the A transpose matrix and multiply two matrices A transpose and A. First we have to find the transpose of A. A transpose is nothing but the given matrix is this, and A transpose is interchanging rows into columns and columns into rows. Therefore 2 into 0 and 3 into 2. This is the A transpose matrix. And next A transpose into A. We have to multiply A transpose matrix into A matrix. A transpose matrix is nothing but 2 into 0 and 3 2, and the A matrix is 2 3 0 2. So after multiplying this matrix we get 2 into 2 4, 2 into 0 0 into 0 0, 2 into 3 6, 0 into 0 0, 0 into 2 is 0, 3 into 2 6, 2 into 0 0, 3 into 3 9 plus 4 into 2 into 2 4. Then we get A transpose into A. A transpose into A is nothing but 4 6 6 13. This is the A transpose into A. Okay. In the next step, find the eigenvalues of A transpose in this matrix. Find the eigenvalues of this matrix. To find the eigenvalues, yourself you do find the eigenvalues, because as we are discussed earlier in the previous classes, so yourself do find the eigenvalues. I will write the direct eigenvalues here. So eigenvalues from this matrix is lambda 1 is equal to 16, lambda 2 is equal to 1. This is the eigenvalue. And arrange them in decreasing order. I arranged the eigenvalues in the decreasing order 16 and 1. Therefore, in the next step, find the singular values. What are the singular values? Singular values is nothing but how to find singular values. We have sigma 1 to find this is this first singular value. We have the formula sigma 1 is equal to lambda into root of lambda 1. Then what is lambda 1 here? The eigenvalues. Okay, eigenvalues. Root of lambda 1 is 16. Therefore, root of 16 is 4. This is the sigma 1 first singular value, and sigma 2 is nothing but root of lambda 2 is equal to root of 1 is equal to 1. First singular value is 4 and second singular value is 1. Okay. In the next step, find the eigenvectors. In the next step, find the eigenvectors corresponding eigenvalues. Therefore, you yourself do it, and I will give the eigenvectors. Yourself do it and verify what are verify is this correct or not. Therefore, the eigenvectors after finding the eigenvector for corresponding the first lambda value is 1 or 2. First eigenvector, and second eigenvector corresponding to the second lambda value. Second eigenvalue is minus 2 and 1. Minus 2, 1. You have to verify is this correct or not, because I will discuss in the I already discussed about this eigenvalues and eigenvectors in the previous classes. You should go through it and yourself do it. Okay, and verify. Okay. In the next step, after finding the eigenvectors, in the next step, fifth step, we have to find the matrices of U, V, and summation. Therefore, first we find V. To find V, we have V1, V2 matrix. V is equal to V1, V2. For V1, we have the eigenvector x1 divided by norm of x1. Which is nothing but x1 is 1 by 1 into 1 2, and norm of x1 is 1 by root of x1 square is this, x2 square is this. 1 square plus 2 square is 1 by root 5 and 1 by 1 2. So it is also equals to 1 by root 5 and 2 by root 5. This is the V1 value. V2, similarly V2 is x2 by determine norm of x2 is equals to x2 is here, x2 is minus 2, 1, and in the denominator norm of x2, 2 square minus 2 square is plus 4, 1 square is 1, root 5. Therefore, V2 is minus 2 by root 5 and 1 by root 5. This is the V1 and V2 value. Then by using the V1 and V2 value, by using V1 and V2 column matrix, we form a matrix V. Okay, V is nothing but what is V? V1. V1 is 1 by root 5 and 2 by root 5, and V2 is minus 2 by root 5 and 1 by root 5. Minus 2 by root 5, 1 by root 5. This is the matrix V. But we have V here. We have to find V transpose. That's all. V transpose by this matrix is 1 row, interchanging rows into columns. 1 by root 5, 2 by root 5, minus 2 by root 5, and 1 by root 5. This is the V transpose matrix. Then we have to find the matrix U. For the matrix U, we have to find U1, U2. Therefore, U is equal to U1 is equal to, we have the formula U1 is equal to AV1 divided by sigma 1. Here, A is the given matrix and V1 is this matrix, and sigma 1 is the singular value. The value of first sigma 1 is 4. Therefore, A into 1 by sigma 1. 1 by sigma 1 is 1 by 4, and V1 A matrix A is 2, 3, 0, 2, and V1 is nothing but 1 by root 5 and 2 by root 5. After multiplying this matrix, these two matrices, we get 2 into 1, 2 plus 3 into 6. Therefore, 2 plus 6, 8 by root 5. 8 by root 5. Then 0 into anything 0, 2 into 2, 4 by root 5. 4 by root 5. Is equals to 1 by 4 into this, which is equals to 1 by 4. So 4 divided 1 by 4, get into inside of the matrix, we get 2 by root 5 and 1 by root 5. This is the U1 matrix. For U2, we have A V2 by sigma 2. Here 1 by sigma 2. Sigma 2 value is 1. 1, and matrix A is 2, 3, 0, 2, and V2 is minus 2 by root 5 and 1 by root 5. Then we get 2 into 2 minus 4, 3 into 1, 3, minus 1 by root 5. 0 into anything 0, 2 into 1, 2 by root 5. This is the U2 matrix. By using U1 and U2, we form a matrix U. That is nothing but U. U is U1, U2. U1 is this 2 by root 5 and 1 by root 5. U2 is minus 1 by root 5 and 2 by root 5. This is the matrix U. So now we have to find, by the use of singular matrix, singular values, we have to find the diagonal matrix. Diagonal matrix summation is nothing but sigma 1, 0, 0, sigma 2. which is equals to sigma 1 is 4, 4, 0, and 0, sigma 2 is 1. Sigma 2 is 1. This is the diagonal matrix. By the use of V, U and summation, we have to verify the final step whether A is equal to U into summation into V transpose of matrix. Okay. We have to verify whether it is equal to A. These are all matrix multiplied together to get equal to A. Okay. A is equal to U summation V transpose. Here U is nothing but 2 by root 5, 1 by root 5, minus 1 by root 5, 2 by root 5. 2 by root 5 minus 1 by root 5, 1 by root 5, 2 by root 5. This is the matrix. And what is the summation matrix? Summation is 4, 0, 0, 1. This is the matrix. Summation matrix. And then V transpose. Here V transpose. This is V transpose. It is nothing but 1 by root 5 and 2 by root 5 minus 2 by root 5 and 1 by root 5. This is the V transpose matrix. By multiplying V, now we multiply these two matrices, we get 2 into 4, 8 by root 5 and 1 into 0, 0. Then 2 into 0, 0, minus 1 into 1, minus 1 by root 5 and 1 into 4, 4 by root 5, 2 into 0, 0, 1 by 1 into 0, 0, 2 into 1, 2 by root 5. Here the next matrix is same as it is, 2 by root 5 and minus 2 by root 5, 1 by root 5. Multiplication 8 into 1, 8 into 1, 8 by 5, root 5 into root 5, 5. Therefore minus 1 into minus 2 plus 2 by 5 and 4 in, and 8 into 2, this is plus, and 8 into 2, 16 by 5 plus minus 1 into 1, minus 1 by root, minus 1 by 5. 4 into 1, 4 by 5, root 5 into root 5, root 5, and 2 into minus 2, minus 4 by 5. Okay, next 4 into 2, 8 by 5, and 2 into 1 plus 2 into 1 is 2 by 5. Okay. Now 8 by 5 plus 2 by 5, 10 by 5, 16, 15 by 5, and here 4 minus 4, 0, and 8 plus 2, 10 by 5. Here 10 by 5, 15 by 5, and 0, here 10 by 5. Therefore, which is equals to 5 1 the 5 2 the 5 1 the 5 3 the 0, 5 1 the 5 2 the. Therefore, the reduced matrix is 2, 3, 0, 2. This is same as the given matrix A. It is same as the given matrix A. Therefore, the given matrix A is singular value decomposes into 3 matrices. One matrix is U, and the second matrix is V transpose, and third matrix is diagonal. Here U and V are the orthogonal matrix, and sigma is the diagonal matrix. Okay, understood? This is the singular value decomposition of the second order 2 matrix.